Hey everyone, Nitesh this side. Hope you are doing good. And sorry for the I didn't upload the videos for the 2 days. Was busy with some work. So let's start with the question. So the question is unique paths 2. Okay. So this question is similar to unique path 1. The Let me just read the question first. So you are given a m cross n integer array grid. Okay, and there is a robot initially located at the top left corner. So your robot is located at zeroth of the matrix, and what it does have the robot tries to move to the bottom right corner. Okay, so robot will be start from the top position, so top left. He have to reach to the bottom right of corner. Okay, so what we have to do, the robot can move only it can either go down or it can either go right. Okay, so we have only two options, and obstacles and space are marked as 1 or 0. Okay, if there is any obstacle, so you can see this obstacle, this will be marked as 1 in the array. So you can know like this is the obstacle, so you have to skip this. Okay, a path that the robot takes cannot include any square, that is obstacle. Okay, so there will be no obstacle in the path. What we have to do, we have to return the number of possible unique path that the robot can take to reach to the bottom right corner. Okay, and the test cases are generated so that answer will be less. Okay, so what the question is asking is like we need to find out the number of paths from this starting position to the end bottom right position. Okay, so it's just simple uh, let me just first write the main function only. So we'll take a solve, we'll pass obstacle grid, and we'll pass the current row, we'll pass the current column. So this is a pretty straightforward question. What we have to do, we either have two options. Either we can go bottom right, or either we can go like bottom or right. So we have only two options. Okay, so we'll write the recursion for that. Like we will start from here from the 0th index. So this will be our current row, and this will be our current column, and we'll pass the basically end row and end column. So our end row basically int m, this will be our row. So obstacle, okay, grid dot length, and your n will be obstacle grid 0 dot length. So this will represent the column. Okay, and we'll pass this row and we'll pass this column. Okay, so we write the solve function for this, and let's call this a array. This I don't, okay, got it. I don't know why they take the too much big name. So int row, and this will be column, and we'll pass the m and int n. Okay, so it's simple. What we have to do, we have only two options. Either we can go right. So for right, your row will be remain as it is, your column will be +1. So row column will be at here, and you will pass m comma n. Okay, and the second option is why I use plus, because we need to count both the path. We need to count all the path. We don't need to return any boolean like whether we can reach or not. We just have to count all the possible path that we can get it. So we'll pass solve, and we'll give row, and we'll this time we need to go bottom, so we'll increase our row, so row +1, and we'll pass column and this. Okay, now you may ask, like, this question is similar to like we done in this week only. There is a question for which we use backtracking. Okay, so you can solve this question by backtracking also. So I didn't use it because there is only two possible outcome. Let's say there are 8 direction I have to go, then I will go with the backtracking because I don't have to write the same statement at 8 times. Okay, so you can try, like you can take a direction of 2 array and you can just take the solve function at a time. Okay, so this will be your main function, like main recursion tree. Now you will write the base case. So base case is if my row is greater or equal to m, I have to return 0. Like I just come out of the out of index. Similarly, if my column is also greater or equal to n, then also it's out of index. And let's say you found a obstacle, so array of row of column equal to 1. So you don't have to move further. So let's say you come at bottom and then you go right. now you can see this is a obstacle, so you can't go further it, and so you just come back here, and from here you will go in this direction. Similarly for this case, if you are at this point and if you go bottom, so there is no, you can move further, so you will roll back to here and you will start again from the right. Okay, and let's say if our row is equal to n minus 1 and column equal to n minus 1, that means we found our valid path, so we just return the 1 from here. Okay, so this will be I think this will be m and this will be n. Okay, so let's run it. I think we have covered all the cases. Let's run it. Only like the difference between a unique path 1 and unique path 2 is like here we mention this condition. Okay, we are getting some error. Oh, why L is there? Let me just run it. Okay, this is accepted, and let's submit it. Okay, it is taking time. So as you can see, we are getting time limit exceed. Okay, so why we are getting time limit exceed? Let's see the constraint. So constraints are not big, but we are called, like if I give you an example, we will come to this direction. Okay, then we go to this direction. Okay, from here also we come to this direction, then we come to this direction. So don't you see, like we come to the same like same vertex that is already visited by another path. Similarly, let's say if, like let's assume there is one more, you come at here, then you come at here and you come at here. Okay, and let's assume there is no obstacle, so you will come at here, you will go here, you will go here. So you can see, if you have answer of this position already, like after this you only take one path to reach your destination, then why you need to come from here and check whether you need one more path? Okay, this is a small example. Similarly, if you imagine there is a 100 cross 100 size of matrix, you can see, you can imagine there will be several vertices or several what you can block will be visited by the same path. So why you have to calculate it again when you have the answer for the previous with the previous path? So what we can use it, we can use a DP. So we'll take our DP and when initialize it, so DP equal to new int m. So we'll initialize with m comma n, because if you can see in the question what we are doing it, either we are changing row or either we are changing column. Okay, so only two things are changes. So let's like this is the rule for DP. Let's say if there are 3 changes are required, so you will create a size of 3 DP, or if let's say there is only row is changing, then you need only 1 DP. 1 DP basically one direction DP, similarly 2 directional array. Okay, and the answer for this either might be 0 or there will be a valid integer because you are doing plus. So what we can do is we can initialize this DP with -1, because there will be no answer for this path that has having -1. So we'll initialize with -1. So we do arrays dot fill a -1. Okay, so whatever our answer we are getting from solve, like first recursion call and second recursion call, we just do DP of row and column equal to, so whatever you got from first recursion and from the second, you just need to do store in the DP. Okay, and there will be one more condition that we add, if DP of row and column is already solved. If it is already solved, that means you have a answer that is not -1. Okay, so you'll check whether if it is not equal to -1, you don't have to call recursion call after that, you can just directly return DP of row of column. Okay, because we already solved with one path, then why we need to solve with different valid path? So let's run it. Okay, this is accepted. Let's submit it. Now let's see if we are getting time limit exceed or not. So as you can see, our code is submitted. So this is a top down approach. Okay, so we are coming from top to down. You can also solve from bottom up, so that's our iteration, but I generally follow top down approach. So yeah, hope you like it. Thank you for watching video, and do join the Telegram group if you have any doubt, any concern. Thank you.